Hello, and welcome to Political Science 4781, Techniques of Political Analysis, Visualizing and Interpreting Data. I'm Professor Brommuller at the Ohio State University. Now what I want to do with this class is rethink how it is that we do data analysis. That is, we, as professors and data analysts, and you as students, and ultimately as citizens. Because the way that we usually do things is highly statistical and highly mathematical. That is, we start out learning means, medians, modes, standard deviations, and we move on to things like samples, confidence intervals, statistical inference, and so on and so forth. Now that's extremely useful for answering a couple of different kinds of questions. The first one is answering the question, what are the odds that this thing that I've observed happened by chance? Now, if you're writing a senior thesis or you're working on a report or something along those lines, and your hypothesis is that you should see something out there in the world, you want to be able to defend yourself against the argument that, well, you just saw that thing by chance, right? So being able to answer the question, what are the odds that you just saw this by chance, is a pretty valuable skill to have. Similarly, one thing that statistics allows you to do is generalize from a sample to a larger population. That is, you can go from the Gallup website and find that the Gallup organization has polled 1,000 people and asked them what they think of the president, and those 1,000 people have given them an average presidential feeling thermometer rating of about 52%. And you want to know how well or how poorly that translates to the feelings of the entire country for the president. That is, you want to know what the confidence intervals are given that the sample size was 1,000. That you can do that using statistical inference, and it's really cool to be able to do that. It's really helpful. But it's not nearly everything that everyone does with data or wants to do with data. And this was brought home to me, of all places, on my Facebook page when one of my former students wrote in and let me know that although she thought the previous version of this class that I had taught, which really was all about mathematics and statistics and statistical inference, was interesting and well taught and so on and so forth, she actually hadn't found any way to use it whatsoever in real life. And that got me thinking, should I really be doing this? Why am I teaching a class that some of my best and brightest students really aren't getting very much out of? And that got me thinking about the context in which I'm teaching the class. I mean, today, not only are there more data available than ever before by a substantial margin, but our relationship to data is changing. We have more ready access to data than we ever had before. And that ready access is one of the things that suggests to me that we should learn how to go out and get data and analyze it and at least come to some basic preliminary conclusions. So that's what this course is all about, data literacy and data visualization. Now, econometrics and statistics are really terrific if you're going to be going into graduate school. The only problem being that you're probably going to have to take those courses over again anyway. Data literacy is aimed, it's also a good foundation for going to graduate school, but it's aimed more at situations that come up more often in more people's lives. That is everything from an argument at the Thanksgiving table, which you could resolve by going out and getting data and turning the data into a straightforward graph, or a situation in which you're applying for a job and your potential boss wants to know what kind of analytical skills you have. Things like this are the things that we should be able to help our students with, because data are really all around us all the time nowadays relative to even 10 years ago. It's really amazing how much information is out there, and it's really critical for us to be able to show you how to take that information and answer straightforward questions with it. Now, this is a practice that's called exploratory data analysis. It was popularized in the 1960s, 1970s by a man named John Tukey, who thought more about it than probably anyone else. But exploratory data analysis kind of fell by the wayside for a while because Tukey didn't really have the tools that he needed in order to engage in it. And I think nowadays we do. We can do it to great effect. Now, what do I mean by data visualization? A lot of people think that what I mean when I say data visualization is creation of infographics. And here are a couple of illustrations to show you what the differences are between the two. On the left is a data visualization. It's a straightforward bar graph, and it's telling you who the main contributors to funding against Proposition 37 in California were. Now, Proposition 37 was a ballot measure that would have forced producers of food to label any food that contained genetically modified organisms, or GMOs. Now, for obvious reasons, Monsanto was the lead contributor to the anti-Proposition 37 campaign. DuPont also weighed in very heavily, and you go down the list and you see a fairly wide range of still fairly big contributors. This is purely informative, right? Now on the right you can see this big graphic that shows, sort of mad scientist beakers and flasks on the left. You can almost imagine the sort of hunchbacked lab assistant off camera, and on the right you've got this beautiful fresh growing plant, and probably off camera Swedish children skipping around, on the mountainside. Now, and if you look in the margins, you can actually see the numbers that you're looking for, although you really don't get any sense that Monsanto, unless you really read the fine print, which is very fine in this case, that Monsanto is a much greater contributor than Hershey or anyone else, right? So the one on the left is really meant to be informative. The one on the right is meant to inform you to a degree, but also to sway your opinion, or to reinforce your pre-existing opinions. And that's not really the job of data visualization. The job of data visualization really is just the facts, to the extent that it's possible to convey them. And we'll talk about some situations in which there are different representations of the data that lend themselves to different interpretations. But our goal in general is to be as true to the data as we possibly can. Now, I will confess that part of my reason for getting you into a class on data visualization is that I think it will make you see the value of doing data analysis, and that many of you will feel more interested than you were in taking a class that teaches you about things like means and standard deviations and statistical inference and so on and so forth. So you can, to an extent, think of me as a data pusher, and that's not a bad place to be as far as I'm concerned. So, what does all of this mean about this course? Well, I think there are a few things that you as students should get out of a course, and not just from this course. You should demand them from any course. One seems almost trivial to say, but sometimes doesn't happen as much as we'd like. Classes should teach you something, right? That is, you should walk out of the class knowing a lot more than you did when you walked in. Number two, they should be accessible. I realize that tuition prices have been going up in recent years, and a lot of families are really sacrificing substantially to put all of you through school. And to the extent that I can, I feel it's my obligation not to increase that burden much at all, if possible. Number three, classes should be interesting. That is, I want you moving on to the next lecture with a sense of anticipation. I want these lectures to be interesting enough that you seek them out voluntarily, not just because you're getting a course grade for them. And finally, classes should... I think a lot of times professors think that the main value of a class lies in its value to sort of the life of the mind, meaning contributes to your ability to engage and to be a good citizen and to lead a good life. And that's certainly true. I'm a big proponent of knowledge for knowledge's sake. But knowledge also has to some degree, play a practical role once you get out of college. Otherwise, there's no value to you to going to college. And so a class that you take should translate to some degree into useful skills that will help you get ahead in the job market. So how am I going to do that? Well, first of all, we're going to use a wide range of online data tools. Now, it's pretty remarkable how many tools there are out there that allow you to do even fairly sophisticated data analysis without having to pay a dime. And we're going to focus exclusively on those. Now, I'll direct your attention to the little R in a circle down in the right hand corner. That is going to be toward the later part of the class, our primary vehicle for doing statistical manipulation. Data manipulation and data visualization. It's a program called R, and it's totally free. It's actually more of a programming language than a program, and it takes a lot more in terms of startup costs than all of the other programs that we're going to be learning. But the advantage is it really allows you to do anything. It allows you to do kinds of graphs that you can't do on any other program. It allows you to specify how the graphs are drawn. Every single aspect of visualization is something you can control in R. So the upshot is it's going to be extremely powerful and let you do lots and lots of things. The downside is you may very well hate it passionately by the time you're done with the class. I'm kind of sorry about that. I'm kind of not. It's really incredibly versatile and a fantastic package to know. It's not a fantastic package to learn to know, but that's all by way of fair warning. Also, we're going to use a couple of programs that cost a little bit of money. Our instructor takes a fair bit of the pain out of learning R. It contains a lot of sort of introductory segments. It's got little video segments like this one. Only they use R to do some of the basic things and show you how it works. It also contains brief summaries of the commands and what they do. And we'll use a program called Outwit Hub. Outwit Hub is what's called a web scraper. It's a program that goes out there on the internet and finds data for you and puts them into an intelligible form. Now, those can be data in the form of like a table on a Wikipedia page, or they can be data like you find in the Census Bureau or in some other websites, where the data that you're looking for is one piece of information on each page, but there are hundreds of pages, right? So Outwit Hub is versatile enough to pull down the data in whatever format they're in. It's one of those things where one of those programs that I'm going to describe it. The time it takes to learn the program is more than pays for itself in the time that you save in gathering data. So it's very well worth having. There's a free version that's got limited capabilities, or you can buy the full capability program. And I think once I saw what it could do, I think I was typing in my credit card number within about 5 minutes. So I highly recommend it. There are also a few books that I'm going to recommend. One is Visualize This. It's by Nathan Yao. He's a graduate student. He has a website called Flowing Data. Really an excellent resource for learning both the sort of nuts and bolts of visualization and bigger picture questions of, here we have some numbers, how do we turn them into an interesting visualization? The middle book, Visual Display of Quantitative Information, Edward Tufte, is the Bible of data visualization. Tufte is a really smart guy. He goes around the country charging hundreds of dollars for his lectures, and you can have them in this one volume. He's actually got 3 or 4 books, but this is the primary one that you'll want to have. The one on the right, the R Graphs Cookbook, is useful. It's got a lot of examples of graphs that you can produce in R frankly, it's one of the best ways to figure out how to graph something in R is to go to Google and ask Google how to do it, because there are tons of examples out there. So the Mitai textbook isn't necessarily as the Mittal textbook isn't really as crucial as the other two, but it's worth having nonetheless. Now, one last note. We don't really tell you in college how it is, what your best strategy for success is. We give you a list of formal requirements, but we don't tell you, all right, now that you've got those formal requirements checked off, here's how you connect the dots to turn this into a course of study that really lets you hit the ground running when you get out of college. Now, my suggestion, since you're in this class, is first you take this class and it'll teach you to be really comfortable with data and data visualization and understanding how data works. That will set you up really well for a second class that does all of the things I've talked about: mean, median, mode, statistical inference, and so on and so forth. You'll be in terrific shape, especially once you've learned R, to move on and take a class like that. Then, once you've done that, you'll realize that, or you should realize, that a lot of graduate courses in your field of study, whether it's political science or something else, use data. So check around and see which classes there are that are being offered at the graduate level, and ask the professors whether it's something that where you could benefit from taking the class, given that you have a background in data analysis. And I think a surprising number of cases the answer will be yes. Whether you do that or not, you'll be in a good position to offer a professor your time as a research assistant. There's you can get course credit for being research assistants for professors. It doesn't cost the professor anything. So generally it's a win-win situation. And then finally, well, not finally, you can do a senior project or a series of projects that show off your skill in data analysis. And then finally, when you end up on the job market, you'll be a lot better positioned to snap up a job that values in some way or another the kind of analytical rigor that you'll be getting from these classes. Okay, that's it for my introductory lecture. Thank you for listening. Next time we're going to talk about understanding data. Thank you.